Hi, this is Nassim. This is homework number 3 of the Recommender Systems class. So in this homework, we intend to implement a hybrid recommender consisting of two components. The first component is the naive base, the content base, and the second component is a collaborative filtering method, which I use SVD++ for. So here, this is the configuration file of the hybrid recommender system. So I read the data in here. It's a sample of the Yelp data where each business has at least 5 ratings and each user has rated at least 5 businesses. So I read the ratings and the features, and I set all of these parameters. I use user facing here, and I use 80% of the data as a training set. So um, I use the ranking method and I evaluate it based on the NDCG at 10. So okay, so I set all of these parameters in here, name of my recommender, and these are the parameters that I've tuned for SVD++, and this is the weight that I need for my hybrid, because I need to combine the results of both of them, and the weights in this project should be equal to 1. So when I set one of the weightings, this is the weighting of the naive base, when I set it to 0.2, the other will be 0.8. So this is the algorithm, for the hybrid recommender. So I will instantiate both of them, and I will take the weight from the configuration file in here. I set up naive base and SVD. I train them in here now, and here I try to calculate the predictions. I take the prediction of both naive base and SVD++ and combine them using this weight. So for the naive base implementation, so I'm using this code. These are some of my parameters that I have: user bias, in rating, max rating, feature log, and this is a metrics, and this is a feature metrics, and which I will use later. So in this part of the code, we are reading the file with the business file, the features, and we are creating our features. So for each item, we know um, we know that we know the feature of that item. If it is set to 1, so we know that we have. So, and also this is a sparse matrix, so it's very compact. So only stores the features that the item actually has. Okay, so here we have stored all of the data in here. Okay, in the train model, we try to train our model. We try to calculate the naive base probabilities, which is this: the probability of like given feature is equal to probability of feature given like, which we have. If we have more than one feature, we have to multiply all of these probabilities, then multiply by our prior, the probability of like, divided by the probability of feature. And also the same thing for the dislike. So for each user, we are gonna see how many items that user have rated, and also what are the features of that item, and also if that user has rated really high to that item, so it means that those features get more rates, um, and so on. So these are some of the parameters that I need. This is dense matrix for storing the log odds. It's the probability of likes divided by the probability of dislikes. This is my feature metrics, which I can get the number of features and the number of users. So this I will use later. So here I initialize this list, the number of likes for each feature with 1. Because later on I need to use Laplacian smoothing, so to avoid having 0 probabilities. So for that reason, I will add 1 to all of the features, so I won't ever get zeros. So in this part of the code, I calculate the average rating of the user, the minimum and the maximum rating of the user. So because I calculate the average rating of the user, so I don't have to I don't have to get a threshold for rating from the configuration file. So I decide if this rating of the user is high or not. So this helps the method to be more personalized for each one of the users, because each user might have different mean rating. So for example, if mean rating of a user is 2, for a user is 2, so 3 for that user, it means, oh, that user likes it. Or so if for a user the mean rating is 4, so 3 means that the user hates that item. Okay, so here for each item I go through all of the features that item has, and I'll get the rating if it is greater than that average rating of the user. So I'll add 1 to the likes, and otherwise I add 1 to the dislikes. Okay, so here I calculate the total number of likes, total number of dislikes. So here for all of the features, I calculate the probability of feature given like and the probability of feature given dislike using this formula, calculating the number of likes for each feature divided by the total number of likes of the user for all of the features. So here I have a matrix which which records the probability, the log out of probability of like for that feature divided by the probability of dislike for that feature for each user. So we can use it later. So here we calculate the priors of the formula, probability of like, probability of dislike, and we store it as a user bias in here so we can use it later. So in this part of the code, we're trying to predict the probabilities. So this is ranking. So these predictions and probabilities are not really good measures of ratings, but they're useful for ranking. So here for each feature, we are adding all of the log odds for each user and feature that we stored before. So for the formula, we need to multiply all of those probabilities together. But since we store them as logs, we can use add. Also, the same thing is true for user bias. So we here add the user bias or our priors in here, and we convert them back to probabilities to get to our prediction. So and to make sure that it's between 0 and 1. Then using the range, we make sure that it's between the range of the rating of the user. It's between the minimum and maximum of the user rating. And here we have our prediction. So I ran it before because it takes so much time, because our SVD++ has goes 25 iterations to get to the result, and also this, but this is my result, one of the results for hybrid recommenders. That's it.